Hello, ELT 132, Digital Electronics. This is Roger Young, and I'm going to give you a video on a very specific topic, and it's called a pull-up resistor. Now, in the book on page 50, they have a definition, and that is as follows. A pull-up resistor, a resistor connected from a point in an electronic circuit to the power supply of that circuit. All right? And a diagram of that, come on, there you go. It's listed right here. Here's your digital circuit, whatever it may be. Now this is an input to it, right? High input resistance right here. That means if you have a lot of resistance, very little current's going to flow, all right? So VCC, that represents your power supply, all right? In your case, it's plus 5 volts. So in this case, when the switch is open, and this is very high resistance, right? No current's going to flow, very little, I should say. This is going to be high, isn't it? So when it's open, your voltage is going to be high, so the logic value will be a 1. When this switch closes, it connects this wire to ground. If it's connected to ground and it's a wire, it's going to be low. And that's what happens here. The switch is closed, it's a logical 0. And when you open it again, it's a logical 1, right? That's pretty straightforward. Now, on page 51, they have 3 other diagrams here. That basically discuss the same thing, right? Just look at the switch, right? Here you have a normally open push button. So if you're not touching it, it's open, that means X is going to be high. It makes sense, right? I mean, it's not connected to ground. The only way to connect it to ground is to press it. And look what happens here. When you press it, boom, you're pressing it right here, everything it goes to ground, right? It's low, it's a logical 0. And it makes sense because you're connecting the wire to ground, right? Finally, when you release it and the switch goes back up and it's open, right? It's no longer connected to ground, then your output is a logic, or this X I should say, is a logical high, right? How about this kind of switch? It's a normally closed. So if you're not touching it, it's normally closed. If it's normally closed, that means this wire is connected to ground. If anything's connected to ground, it's going to be low, right? So you're starting off with it low. When you press it, you're going to create an open, which means it's no longer connected to ground. Hence, you're going to have a logical 1, right? It's going to be high. And finally, when you release it, it's going to be, the switch is going to close again. It's going to be connected to ground, and hence it's going to be low. All right? Now, here's when they combine them. It's a 2-pole push button. So obviously, if you have a normally closed, that's what the NC stands for. Normally closed, NC stands for normally open. And these, when they say normally, like, that means if you're not touching it, right? You're not pressing it, you're not doing anything with it, it's closed, all right? So normally, it's closed. So in this case, if you're looking at the top one for X, it's normally closed. So in that case, it's going to be low, right? And they show X, which is your output here, is being low, right? And then when you press it, that means this switch is going to be open and this switch will be closed, right? Hence, X is going to be high and Y is going to drop low, right? And then when you release it, it's going to jump back to the way it was in the beginning. So this is a way of just combining these 2 switches into one circuit, okay? By the way, the normally open, which I don't know if I said this or not, but if it's open, there's no current, there's no way the current can go to ground here, so it's going to start out high while X was low. And then when you press it, obviously, Y goes low and X goes high. I hope this concept I got across to you pretty well. It's not really a difficult concept to get, but all of these use pull-up resistors. If you notice, they're all drawing their power from the VCC, right? And depending if that switch is connected or not depends if that wire is connected to ground. And quite simply, if it's connected to ground, it's going to be low. If it's not connected to ground, it's going to be high. And that goes with this one assumption that the input impedance, which is basically resistance of this circuit, is very high. So there's very, very little current flow taking place. I hope this video has been helpful to you. And if you have any questions, please let me know. Thank you.